We're talking about piecewise functions today, and as always, we look at functions through the rule of 4. So we're going to look at piecewise functions as a written description, a graph, an equation, and a list of values. And here we have our written description. A piecewise function is a function defined by multiple subfunctions, functions within the function, where each subfunction applies to a different interval in the domain. So take some care to write that down, and we'll talk about exactly what that means. So it's a function defined by multiple subfunctions. So imagine we have a graph, a line here. Let me do that over again. It's a line that goes through like that, say there, okay. And then maybe does something like this. So it sort of has like a linear part and a parabolic part, a quadratic part, and you're like, oh, now I get what she means. Multiple functions within the function, multiple sub-functions. And we can say that this whole thing together is a function because there are no multiple values for x. For every one x value, there is exactly one y value. And I'm just trying to get this really pretty here for you to see. So if we look at it like that, there, that's nicer. We can see that there, even as we do a vertical line test, we see that there is no line. Even if we were to draw the vertical line right here, we see, oh, it actually doesn't go through this point because that's an open circle. Okay, so the point 2, 1 is not actually part of our graph. So if we were to look at this, we have a line, we've got a parabola. Could we write the equation of this piecewise function, the function that has multiple subfunctions? We can. The answer is always yes, we can. So we're going to start with f of x, and then we're going to do this. We're going to say there are two parts to this function, and so we're going to encapsulate them in this bracket. And so the first part of this function is the linear function, and that looks like, that just looks like the line y equals x. So instead of writing y equals x or f of x equals x again, we just say x, and then sometimes you'll see a semicolon or a comma. And then for the domain that this is part of, so my domain starts at 2 and it goes all the way back to negative infinity, or maybe we would say it starts at negative infinity and goes all the way to 2, and it includes 2. So we would say it's the line y equals x for the domain x is less than or equal to 2. We will then also say what this equation is, and that's a parabola whose vertex is at 3, 0. So my parabola has been translated to the right 3, so I'll call that x minus 3 squared for the domain. And then we have to say, well, what is this domain? Well, this domain is x is greater than 2. Noticing that our value approaches 2, it gets very, very close to 2, but it won't actually be 2 on the x-axis. That's where we're looking. And so this is how we list our piecewise function. And you'll notice that we have two different domains. We have the domain from 2 this way, and then we have the domain from 2 this way. Right? Does that make sense? And as we think of these two domains, we can color code them there. And actually, let's do the whole thing here, right? This part here and this there. So then when we ask questions, if I want to say, hey, can you tell me what the value is for f of 5? Well, f of 5, you've had to look here. You have to look at the domain here. So which one does 5 belong to? Well, it belongs to greater than 2. So then I use this for figuring out what f of 5 is. So I would say, well, that's 5 minus 3 squared. 2 squared, also known as 4. Oh, look, I can see it. It's right there. Ha ha ha, duh. If I wanted to say, well, then what is f of 0? I'd have to look at the appropriate domain. F of 0 is going to be 0 is less than or equal to 2. So f of 0 is going to be x. I can use that equation, 0. Or I can look at the graph. Oh, it's 0. Great. We're going to do one more, one final one. The hardest one of all, I would say, is this. What is f of 2? This is where we get tricky because you look at 2 on your graph and you're like, well, do I choose this one or do I choose this one? The open, closed circle, open, you choose the closed circle. It's at 2 for y. So you say when my input is 2, my output is 2. Or you could look at the equation. You know that equal symbol means, oh, it's going to be whatever x is, 2. We're going to look at another example in another video.